Okay, so let's get started. We gotta get back to page 58 where we left off before. It's a little hot in here. And let's get it going. Oh, excuse me. Let's pull this out. Okay, let's go. So, yeah, it still looks big enough. Okay. All right, so we were left on page 59 actually. We finished reading here the result of the program and the comment there afterwards. When you allocate memory for a multi-dimensional array, you need only specify the memory for the first leftmost dimension. You can allocate the remaining dimensions separately. Hmm. Okay. And now let's see at the chart here, at the image. Okay. Page 59, and this is the right index determines column. Okay. And left index determines the row. So 4 was the row and 5 was how many columns. 4 was 1, 2, 3, 4, and 5 was 1, 2, 3, 4, 5. So it was 5 columns. It was four rows and of 5 spaces each. Okay. So as you can see, um, 0 1 0 0 is 1, 0 1 is 2, 0 2 is 3, 3 is 4. Oh, actually 5 columns. Okay, I'm all confused. Right, I'll say 5 columns. So 5 columns of 4 rows each. 5 columns of 4 rows each. Got it. Okay. Um, man, I already went through this. I don't know why I got confused there. Okay, so here we go. Okay. Okay, so each column has 4 spaces. Pretty clear. Okay. So give int, okay, to the new int, yeah, 4 and 5. So that's what that's talking about. The 4 is how many across, and the 5 is how many columns. Okay. Yeah. But that should read backwards, really. Maybe I'm crazy here, but that should read backwards because 1, 2, 3, 4, 5 columns, but it's really 5 rows. What we're seeing here, and well, technically 5 columns, yeah. And the rows are downwards. Yeah, rows are sideways. Excuse me, columns are sideways. Rows are downwards, like in an Excel sheet. Okay. All right. All right. A conceptual view of 4 by 5 two-dimensional array. Okay, so let's keep going. Let's pull this up a little bit. Okay, let's see. And for example, this following code allocates. Oh my God! Hold on. Let's turn on the Pomodoro. I was going to do that again. Pomodoro, where are you? Right here. Okay. And let's do. Okay, let's do 25 minutes for Pomodoro. Okay, give me a moment. I got it. I'm starting the timer. Yeah, 25 minutes. Okay. Here we go. Okay. All right, great. Okay. Excuse me, guys. All right, so okay, for example, this following code allocates memory for the first dimension of 2D. Okay, when it is declared, it allocates the second dimension separately. Okay. Oh wow. Look at that. Oh, this is really good because wow, you could really play with that. You're literally allocating how many columns per row. So not all rows have to have the same amount of columns. That's what that is saying. That's really good. So not every row needs to have the same amount of column. Or am I getting ahead of myself? Let's see. Let's see. Well, there is no advantage to individually allocating the second dimension arrays in this situation. There may be in others. For example, when you allocate dimensions individually, you do not need to allocate the same number of elements for each dimension. There it is. See, this is a little thing I didn't learn in the course. Wow. I thought you always had to have the same amount of columns. As stated earlier, since multi-dimensional arrays are actually arrays of arrays, the length of each array is under your control. For example, the following program creates a two-dimensional array in which the sizes of the second dimension are unequal. Oof. Ooh. I am so glad I'm reading this book. Okay, let's see. Let's bring up the code. Okay, so for one part is on this page, the second is on the other page. So let's read this one first. Manually allocate different size dimensions. Class 2, D again. Public static void. Okay, yeah. And then the first dimension is four. That is 4 rows. 1, 2, 3 rows from up and down. And the second one is saying in this index, give me this many columns. Oh my god, that is so crazy. My mind is running with ideas. Like I can see the space for a lot of creativity here. Wow, I like that. Let's look at the second part of this code. Wow, yeah. All right, we're gonna code this now. Okay. So this is the output that we should be getting right here before we code it. Okay, that's the output. All right. So let's go and get to coding, and we're going to do nano 2D again .java. Okay, and we're going to activate our composer, and I need to adjust the page here so that I can see the full code so that I can type it. Oh. Okay. So I'm actually going to just bring this smaller a little bit because I'm looking at the other document behind it. And okay, here we go. Okay, so you know what? This is a pretty cool feature, but actually I'm not gonna use it because even though it makes it faster, at the same time I'm lacking practice using Nano, so I'm gonna stick to this as hard as inconvenient as it can be. Manually allocate differing size second dimensions. Okay. Class to the again. Okay. Now let's go. All right. So static. Let's put that at the top. Public static void. Okay, main string yes. My second bracket here. Int boom boom 2D No, that's not it. 2D. Okay. No int. Oof. No. If it was a chart, that could be right because the 8 has a numeric value, like the charts can be translated as we read earlier, but we're not going to mess with that. There's no need for that at all. Okay, so no int. Actually, it's no int 4, and you declare the spaces, and then let's now this I'm gonna have to copy because I don't want to repeat this so many times. So let's mark it T. Okay, and new int. Excuse me. Okay, so take it out, put it back in. Okay, so now 1 and 0. Okay, so next. Okay, and this was 2. Oh, of course we're gonna do that. 0. Next line. Okay. 3. 2. Okay. So next line. Okay, so 4, and this is 3 right here. Okay, next line. Okay, and 5 and 4, and I think we're good. Let's check the rest of the code. Okay. Okay. One more line. Int I j k. Okay. 0. Okay, let's see the rest of the code, what it does. Okay, so here's where we start our for loops. For, and I think I gotta copy this twice also. For I equals, okay, I less than 4, I plus plus. In this case, there's a bracket. No, there's no bracket in this case. Okay, and then for j equals 0, j greater than I plus 1. Oh. Okay. Increase j. Okay. Now we're going to copy that and input it. Okay, so we have the information there, and I don't have to type it twice. Our bracket, and then 2d I j. Okay. Okay. There's a last bracket for that. Okay. So now we're going to do the same, and we're going to copy the code here again. Okay, except that this time we have the same code, but there is a bracket here. Okay, so I'm going to put that bracket right there, and I will go to the second line, and then under this one, system that out that. Okay. Print. Okay. To the okay, I think I'm not missing anything there. Okay, and then again on another. Yep, another one. this is just a print line. Okay. So basically that prints a space. Alright, so now here we're going to put our bracket right here. So we know that that's where it ends. And I should actually put that bracket up there. There we go. And then here, and then here. And I think we're good. 2D again, yes. Okay. Think I'm not missing anything, and I think we're good to go. I think we are good to go. So now let's run it. Well, let's compile it. Okay. Why can't I see? See, the only thing is that the timing. Like when I put the time, this shouldn't really. It should wrap around. That's the only thing that they did with this that I find wrong. So I'm gonna have to take the time again. Really sucks is the letter should be wrapping around the timing, and I can't see it. So give me a quick second so I can fix this, and we will be right back. Oh, my screen. There we go. Let's see. Okay, we're right here. And I probably should have paused the video and I didn't. So let's look again. So let's look. Here we are. I took the timing off. Now I can see. Let's compile. No mistakes. Great. 2D. There we go. Okay. All right. So let's run it. Index 4 out of bounds for length 4. Oh, what just happened? Oh my god. Okay. 0, 1, 2, 3. 1, 2, 3, 4. Oh my goodness. Okay. How did I do that? Okay, so I forgot you can't do this. And now let's go ahead and delete this whole line. Wish there was a way to delete like this whole line. I gotta find a way to like the for the. Okay, let's see. Okay, to delete a full line in full. Okay, line in macOS Terminal Nano. Let's see. There should be a command for that. Oh, Control K cuts the full line. Oh, look at that. I didn't know that you could actually do that. Well, that's interesting. There it is. Control K actually cuts the whole line. All right, so there we go. So let's save it. Let's get out. Let's compile again. Okay. And now that we compile it, let me first clear. And then let's run it. Okay, there's an error here. What happened there? Okay, because that's not the code that is supposed to print out. So I made a mistake here somewhere. Okay, this is the code that's supposed to print out. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, so let's see where I went wrong. Okay. Let's see where I went wrong. Okay. 1, 2, 3, 4. Okay. So the issue has to be on the code here. Okay, so first one, for I equals 0, I is greater less than 4, increase I, and then for j equals 0, j is less than I plus 1, increase j. Okay, and then we have, oh my god, I didn't increase j, that's what happened. It's right here. Right here. Okay. Okay, I didn't increase j, so it is, I mean, it increased k. K plus plus right here. Okay, let's save that. Okay, k plus plus. Okay, because cake had not been given any value, so I have to increase it. Oh my goodness, no wonder. Okay, and then the next, let's check it just in case. For I equals 0, I is less than 4, increase I. For j equals 0, j less than 1 plus I plus 1, increase j within the brackets. Okay, and then system, yeah, now that is correct. Now that's correct, so we can get out. Okay, and let's run it again. Oh, wait, I have to compile. Oh my goodness, I have to compile it. Hold on, I have to compile it. Okay, we have to compile it a second time. Okay, and now we can run it. Now that's more like it. See, now that's what we're looking for. Okay. So if we look here, that's absolutely the correct outcome. Okay, so let's see. Okay. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's correct. That's correct. Okay. All right. Okay. Let's see. That's pretty nice. Okay. So let's read on the next line and say, okay, so the array created by this program looks like this. And that's exactly what the actual answers look like too. Right there. And I guess that's the index. Okay. 3031, 32, 32. That's the name of the columns. The name of the columns and the rows. The first one had one column, right? So the first index had one column. It gets 4 rows, but the first row only has one column. So rows is spaces from the top bottom, right? How many lines basically. And columns is how many lines vertically. So no, horizontally. So how many lines vertically, how many lines horizontally. So the columns are how many lines horizontally, which was 1. And then 2. And then that's the name of the index. 1, 0, 1, 2, and 3. Those are the name of the index. And then the rows. So 0, 1 are the names of the columns, excuse me. 0, 1, and 2 are the names of the columns on the index number 3. And 0, 1, 2, 3 are the names of the columns in the index in row number 4. So if we look back the code, that's what this is. It's pretty neat right there. Yeah, that's pretty good. I like that. Okay, so let's go ahead and keep on reading. The use of uneven or irregular multidimensional arrays may not be appropriate for many applications because it runs contrary to what people expect to find when a multidimensional array is encountered. However, irregular arrays can be used effectively in some situations. For example, if you need a very large two-dimensional array that is sparsely populated, that is, one in which not all of the elements will be used, then an irregular array might be a perfect solution. It is possible to initialize multi-dimensional arrays, and to do so, simply enclose each dimension's initializer within its own set of curly braces. Oh, nice. Okay. The following program creates a matrix where each element contains the product of the row and column indexes. Okay. Also notice that you can use expressions as well as literal values inside of array initializers. Oh, that's pretty good. Wow. I mean, your mind just starts running when you think of things like this. This can be put to very clever use. Wow. Let's see. Let's look at the next program. Initialize a two-dimensional array, class matrix. Ooh. All right. Let's see it. Double. Here we go. Okay. So we have 1, 2, 3, and 4. Okay. Nice. Okay, let's type it and we'll understand it better as we go. Okay. So it looks like literally the way that this is positioned is you're literally seeing the rows and columns in the same order as they are stacked here, and that is a pretty good visual cue because it really helps understand how the outcome will be. And that's of course the outcome right here, verifying that it really matches the order in which the array is visually set up here. It really does. It matches every single operation. Okay. Very nice. This way you don't need to understand it mathematically. If you understand it visually like this, you're good to go. At least when you're initializing arrays, that is, okay, two-dimensional arrays. Okay. All right. So let's go ahead and do this. Let's get back to Nano and create it. Okay. So Nano matrix.java. Okay. 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 Class matrix. Okay. Okay, and now let's look a little further down, look at the whole code so I can just do it right here. Okay. Let's see if I can just make this, okay. There we go. Okay, so, it's been 25 minutes. So we gotta do this quickly. Okay. Double and then first and then second bracket okay, you know what, This may not seem like much, but it actually will help. Okay, 0, okay, and then 0, 1, 0, 1, and then 0, 2, no, 2 times 0, okay, 2, okay, 0, okay, and then 3, 0, and close the first bracket, comma, second bracket, 0, 1, and 1, times 1, and 2 times 1, okay, everything is times 1, then 3 times 1, close the second bracket, okay, open the third, and that is 0 times 2, then 1, oh, I see. It determines the multiplication, and then 2 times 2, and then 3 times 2, yeah. Okay, and then the next one is 0 times 3, and then 1 times, 3, and then 2 times, okay. So times 3. Why is he doing that? Okay, and then 3 times 3. Alright. Okay. And then the last bracket, last closing bracket, and the ending. Okay. 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 Now here we start. 4 I equals 0. I is less than 4. I plus plus, and then okay, we open a bracket. Okay. All right, and then let's 4 j equals 0. J less than 4. Okay, j incremented. Okay. All right, and then okay. All right, print. That's fine. J. Okay, and then another system that out print line for the space. Okay, and I think that is our whole program. So now we get to close this bracket here, close our main method, and then close our actual program. Save it, matrix Java, yes, let's get out. Let's okay. Compile it, hopefully no errors. We're good to go, and then run matrix, and there it is. Results. Oh my god, I am so sorry. I didn't realize that I changed the thing. Alright, so there it is. Here's the program coded. Okay. Let me bring this down here. Okay. and there is the program running. There it is. Okay, so 0, 0, 0, 0, 0, 0, 1, 2, 3, 0, 2, 4, 6, 0, 3, 6, 9. And that is the outcome that should happen according to this right here. There we go. All right. So it's time to pause. We're left on page 61. Okay, and then we're going to demonstrate a three-dimensional array, looks like. Look at this. Three-dimensional array. Oh, that's pretty cool. All right. Well, thanks for